7.1 starts off with differential equations. So, quick notes. A differential equation is an equation which involves the derivative of a function, and the solution to a differential equation is a function, not a number. So, for example, the solution to the differential equation y prime equals x over y is y squared minus x squared equals c, where c is a constant. So, can you think why y squared minus x squared equals c is the solution to y prime equals x over y? Go ahead and pause the video, see if you can figure that out. And pretty much y squared minus x squared equals c is a solution because when we take the derivative, now that we know implicit differentiation, we're just going to take this, the derivative here with respect to x, and we're going to do it implicitly. So this is 2y times dy dx minus this one right here is just 2x, and then the derivative of any constant is just 0. So if we want to solve for dy dx, we want to isolate it. So I'm going to add 2x to both sides to get 2y is equal to 2x. And then when I divide both sides by 2, and this is times dy dx. And actually, I'm going to divide both sides by 2y. Getting a little ahead of myself. And when I do that, I get that dy over dx is equal to x over y, or y prime is equal to x over y. So that's pretty much y. So when we take the derivative of y squared minus x squared equals c, we get y prime equals x over y. So this is called the general solution, since we have a family of curves with an infinite number of choices for c. So the general solution is y squared minus x squared equals c. Okay, moving on to another note. The order of a differential equation refers to the highest order derivative in the equation. So, for example, we have y double prime plus 4y equals 0. This is a second order differential equation. Okay, we look at the highest order. So, because it's a double prime, it's second order. So let's look at an example. Find all functions y that satisfy dy over dx is equal to secant squared x plus 2x plus 5. So let's look for that general solution. And so the main idea is to integrate. So kind of behind the walls, what you're doing is we're going to break up this dy over dx. I'm going to break it up by multiplying both sides by dx. To then get dy is equal to secant squared x plus 2x plus 5 dx. And then pretty much what I'm doing is then integrating both sides. The left side of my equal sign is with respect to y. So this one's with respect to y. And the right side is with respect to x. Okay? So if we integrate both sides, let's look at the left side. We have a 1 there. That's integrating dy. It's like saying integrating 1 dy. So that's pretty much the integral of 1 with respect to y is just y. Integrating secant squared x plus 2x plus 5, well, that's not too bad either. What we get is tangent x plus x squared plus 5x. Now, notice that this is an indefinite integral. This is indefinite. We do not have a lower limit or an upper limit, so we have to do the infamous plus c. And that's your answer. So we have, what this says is that we have a family of functions, okay? C can be any value, any constant. When we take the derivative of it, no matter what c is, no matter what the constant is, we'll always get secant squared x plus 2x plus 5. So in this case, we have pretty much a family of functions. When we are given an initial condition, we can find a particular solution. Okay? So let's take an example for that. So copy this one down. Find the particular solution to the equation dy over dx is equal to e to the x minus 6x squared, whose graph passes through the point 1, 0. So I want you guys to pause the video and give this a try. So start this pretty much how I did the last one, and then you guys give me the family of functions, and then I'll show you how to use a particular, or use the initial condition to find a particular solution. Okay, this should be your first step. Okay, break up the dy over dx. And then once you integrate both sides, you get y equals e to the x minus 2x cubed plus c. But we have an initial condition. Okay, the point 1, 0. In the point 1, 0, x happens to be 1, y happens to be 0. So let's go ahead and plug that in. So we have 0 is equal to e to the 1 minus 2 times 1 cubed plus c. Okay, so then go ahead and do that work, and you get c equals 2 minus e. Okay, so now we have something to plug in for c. Okay, so we go right back to that family of functions that we thought we had, but we don't really have a family this time because we have an initial condition that'll help us get the particular solution, which in this case happens to be y equals e to the x minus 2x cubed plus 2 minus e. So you just plug in your new c value, the 2 minus e, you plug it in for c, and that's your answer. And I'll stop the video here. Nice and short video. I'll see you guys in class.